Today we're looking at segment and angle addition, but before we get going on what that is, we need to talk about a little bit of vocabulary that might help us out. So first thing, our vocab, complementary, you've probably heard that word before. That means if you have two angles, their measures are going to add to 90 degrees. So in other words, when we put them together, that might make a right angle. Supplementary angles are angles that add up to 180 degrees. In other words, they make a nice straight angle if we put them right next to each other. But we don't have to. We could have a 40-degree angle and a 50-degree angle totally separate from each other, but they're still going to be complementary to each other. So we could have angles right smack up next to each other, or we can have them separated. It really doesn't matter when we're calling them complementary or supplementary. All we're focusing in on is what do their measures add up to. Another thing that we're going to start looking at is how can we start comparing objects. So when we're looking at diagrams, we need a way to represent that when we write it down. We can't always be right there to explain to somebody what we mean. So if we're looking at angles that are congruent to each other, the way we can mark that is by putting a matching arc in the congruent angles. So these two angles, these are actually pictures that I cut and paste, and one is just rotated from the other, but they are exactly the same image. So if I see a single arc through both of them, I know they're congruent to each other. And we can use as many of these as we want. So if you have a bunch of angles in the same diagram, some of them might have a one arc to show they're equal, and then others might have double arc to show those are equal. You might also see the arc with a little dash mark on it. Again, depending on the resource, depending on who's writing things out, you might see that if I've used pictures from other resources. But honestly, I tend to use just the arcs when I'm marking those. To mark congruent segments, we use just a dash mark. And again, if you have multiple segments in the same diagram, you may see where you have some that have one and some that have two, just to show which ones are congruent to their kind of pair and which ones are congruent to a different segment. But those, we're always using a dash mark to mark those. Okay. Our two big rules that we're looking at today are the angle addition postulate and the segment addition postulate. Now, you've probably not heard that word postulate before, but it's really just a substitution for here's a rule that we need to follow. Someone has gone through and proven that this rule is always going to be true. And so with these two addition postulates, these are rules that basically say that if you take one object and you add it to another object, add those together, you get the full object. So if I have two angles, angle 1 and angle 2, and I add them together, then that number when I add them together is going to be the measure of that whole big angle. A little bit more mathematically, we see this as if D is in the interior of angle ABC. So in other words, we have point D here, and it's somewhere inside the space of this angle. Then I can actually say, having that new ray going through segment or going through points B and D, so ray BD, I can say that angle ABD, so this one, plus angle DBC, this one, when I add those up together, it's going to equal the whole angle all on the outside. So that will equal angle ABC. Now, notice how I'm naming these angles, and this is very important as we keep moving on through geometry. I'm basically tracing through the points that are labeled on that angle. So angle ABD, ABD, I traced right straight through in order to say here's where the sides of my angles are, or sides of my angle are. And I want to think, what's that opening? That's really the angle that I'm worried about. Same thing, DBC. If I actually take my pen or pencil or finger and trace through point D, then B, then C, kind of traces through the sides of the angle that I'm referencing. Okay, same kind of thing happens with segments. So if I have one segment, I'm going to use a pen, one segment plus another segment, the length of the whole thing is just going to be that entire measure, adding those together. And that's all the segment addition postulate is. So we have two things listed. Points A, B, and C are collinear. So again, that word collinear might be new, but take it apart. Co means together, and linear means having to do with a line. So if I put those together, it's collinear is together on a line. Okay, so points A, B, and C are all together on the same line. Okay. Point B is between A and C. And that would be a way to describe where B is compared to our two endpoints, A and C, if we're just looking at the segment AC. So this is really just referring to this segment AC. It's drawn on the line because, again, keep in mind, a segment is just one specific piece of a line. So if all of that stuff holds true, B is stuck in between A and C, and all 3 points are collinear, then I can say that segment AB, or the measure of segment AB, plus the measure of segment BC is going to equal the whole entire segment, segment AC. Okay, and you have a note, if you already printed this up, you already saw this, but the note I have right below here is part plus part equals whole. And that's really the big idea, whether you're dealing with angles or you're dealing with segments. If you have two or more parts that you add together, they have to add up to make the whole. And so we just need a way to practice this or visualize this. And the more of these diagrams that we see, the easier it's going to get. But just keep remembering part plus part equals whole. If you know any info about the 2 parts or 3 parts or however many parts they gave you, add them up together and set them equal to whatever the measure or info is for the whole object. So let's try some angle examples first. So again, the 2 angles would have to add up to make the whole thing. Here we go. So first one, if angle WXZ is equal to 48 degrees, and measure, and that's what this little m means. This means the measure. So anytime I'm giving like 31 degrees or 48 degrees, I'm giving the measure of an angle. So the measure of angle WXZ is 48. The measure of angle YXZ is 31. Then what's the measure of WXY? Wait a second, let's think of this. WXZ, so which angle is that? Trace along the picture. So WXZ, wait a second, that's the whole angle. So I like to kind of do this arc along the whole side if I need to. If I have overlapping pieces, I've got to do something to organize my info for myself. That whole thing is 48 degrees. Okay, angle YXZ. Let me do a different color. So YXZ, so I'm going to trace through. Here's YXZ. So this is just the lower piece of it. So that's 31 degrees, just that lower part. The question is, what is angle, or what's the measure of WXY? Well, WXY, so that's this angle in here that we're looking for. So if I took the purple part plus the blue part, the 31, they should add up to get 48. So I'm actually going to write an equation for this. So again, my model is always part plus part equals whole. Our whole angle was angle WXZ, which was 48 degrees. Our parts were our purple section. I don't know what that measure is. So what I'm going to actually do is I'm going to give that a variable. Let's just call that cursive X. So the purple part plus the blue part is going to equal the whole angle, or in this case, the red part. So wait a second, that's just an equation. That's like X plus 31 equals 48. So all I need to do to solve for X is do what with the 31? Okay, so let's subtract 31 from both sides. 48 minus 31 gives me 17. So that means the measure of angle WXY is that X value that we solve for. It's 17 degrees. Part plus part equals whole. Always remind yourself of that when you see any of these problems. So let's look at another one. So number 2, if the measure of angle ABC is 88 degrees. Okay, So A, B, C, the whole angle is 88 degrees, not just one piece, both parts together. So again, if I want to give myself that mental map, part plus part equals whole, and the whole thing on this one is the 88 degrees. Notice I still haven't even read the whole problem. As soon as I got some information, I started writing it down. I want to do something to organize my info. So let me go through and read it again. Let me see if I missed anything. So if the measure of angle ABC equals 88 degrees, then find X. Well, the only place I see X is actually those little expressions. We've got the 2X here and we've got the X minus 2. But those are labeling the two different parts. So we've got the top part and the bottom part. Well, if I add my parts together, they make the whole thing. So in other words, if I add together 2x degrees and x minus 2 degrees, I should get 88 degrees. Now I don't really need to write out the degrees part, so let me just write that as a normal equation. So 2x plus x minus 2 equals 88. Why do you think I put parentheses around there? I left them off of 2x because I only have one term. But x minus 2, again, going back to your algebra, we've got two different terms in there. So we need to be really careful that we keep in mind, you know, all those negative signs that we might be dealing with. Now I have a positive on the outside here, so this guy. So I don't really have to worry so much on this problem. If I had a negative there, I would definitely want to distribute over everything in the parentheses. But right now, all I need to deal with is 2x plus x minus 2 equals 88. And again, the more of these that you do, you might not need to write all these steps, but it's never a bad idea to put every single one of your ideas down on paper. So to solve this out, I need to combine like terms. So 2x plus x will give me 3x. Then to get the x by itself, what do I need to move first? Okay, always do your addition, subtraction, moving first. So I'm going to add a 2 to both sides, so 3x equals 90. And then to solve for x, divide both sides by 3. 90 divided by 3 will give me 30. So my answer for x is 30. Again, you might not need to write down every step, but you absolutely want to show your work on these kinds of problems. Even if you're doing a problem where you're just entering your answer online, write it down. Keep yourself organized. Okay, 2 more problems on angles. Here we go. Number 3, wait a second. Number 3 and number 4, I didn't actually put any picture, so we might need to draw something. Okay, so number 3, ray RT bisects angle QRS. Wait a second, that's kind of like what we were doing in our constructions last class. So if I'm going to bisect an angle, that means, wait a second, I'm cutting him perfectly in half. So cutting my angle in half, how do I mark congruent pieces again? Okay, use an arc. I'm going to go ahead and label my letters so I know what's what. So ray RT bisects QRS. Notice my R is in the middle, so if I trace through my angle, that means I'm going to have angle QRS. RT is the bisector, so R and then going out to T. Okay, given that angle QRS is 60 degrees, so QRS, so that's the whole angle. The whole angle is 60 degrees. What other measures of QRT and TRS? So QRT is kind of the left, almost top half, and TRS is the bottom half. Well, I already know that those two pieces are equal. So if I wanted to turn this into an algebra problem, I could say, well, these two pieces are equal. Let's call them the same thing. I'm going to use x as my variable. I don't know what x is, but I know both of them would have to be the same thing. And so if I do part plus part equals whole, my part plus part is going to have to equal 60 degrees. But let's see, x plus x, well, that's really 2x. And to get x by himself, divide both sides by 2. So x equals 30, aka angle QRT, or rather the measure of angle QRT, is equal to the measure of angle TRS, and they are both equal to 30 degrees. Okay, our last problem is kind of playing on your info that you already know about angles, plus the part plus part equals whole. So we're actually going back to doing a word problem. I know everybody's favorite, but I still want to use that same terminology on this one. So I'm going to read through, write my equation, read through again, make sure I got all of it. P and Q are supplementary angles. If the measure of angle P is 3 less than twice the measure of Q, what are the measures of both angles? So I have kind of a few different things I'm dealing with. So I have angle P and I have angle Q. They're supplementary angles. So overall, I know I'm going to have to do a part plus part equals whole. But if they're supplementary angles, what's the whole? What are they going to have to add up to? 180 degrees. But then I have to deal with that middle sentence. If angle P is 3 less than twice the measure of Q. So we're comparing P to Q. So I'm going to write everything in terms of Q. And I'm going to use the variable Q because then I don't have to do any extra translations or rewriting or anything. P is 3 less than twice the measure of Q. Well, how would I write twice the measure of Q? So that would be 2Q. So then expand it a little bit more. It's 3 less than twice the measure of Q. Well, 3 less than means what operation are you doing? Well, you're going to subtract, so minus 3. So angle P is really the same thing as 2Q minus 3. And so there's our two angles. So I'm going to use, here's my angle Q, and here's angle P written in terms of Q. And so that's what I'm going to fill in. So we have Q plus 2Q minus 3, and there's our equation that we can solve. Okay, so we have a Q and a 2Q, so I can put those together to make 3Q, still have a minus 3. Okay, then just solve out for Q. So I need to add 3 to both sides, so that's 183. So wait a second, I'm not probably going to have a very good value on here. I do need to divide both sides by 3. So 183 divided by 3. Hey, looky there, it actually comes out pretty nice. 61. So that means I've got, so Q has a measure of 61 degrees. And if I substitute that in for the statement I made for P, that's going to be 2 times 61 minus 3, aka 2 times 61 is going to be 122 minus 3, otherwise known as 119. So angle P equals 119 degrees, or measure of angle P, measure of angle Q is 61. Double check that. So double check, does 19 plus 61 equal 180? As long as it does, you found the correct answers. Awesome. Okay, this might not be a bad time to pause the video if you need a break or go back through and review those angle problems, but I'm about to go through the segment problems next. Okay, segment problems. So again, same idea is going on this. If you have multiple pieces, part plus part equals whole. So our first example, actually all of these examples, the overall directions, we're just going to solve for x. So every single one of these, we're just solving for x right now. So in example number 5, you'll notice I have those marks in there. We have a little dash mark on both sides. So what did those marks mean again? Okay. They mean we have congruent segments. So that means we actually have 2 congruent pieces on here. So if I already know that the parts are equal, then I can just set them equal to each other. So I can say that 6 equals 2x. So all I need to do to solve for x, divide both sides by 2, so 3 equals x. Or if you're like me, sometimes you like having the x on the left-hand side, I can switch that order. Doesn't really matter which way, x is equal to 3. So that one was pretty quick. And it really just went on, hey, we have congruent pieces. But number 6 is a little different. I gave you a diagram, and then you have some things describing those different segments. So first thing I would do is let's go through that info and label it on our diagram. So first one is RS equals 5x. Okay, so I'm just going to label a 5x right above my segment. Okay, so the next one is ST equals 3x. Okay, well, that doesn't necessarily look proportional, but my diagram doesn't have to be proportional. It's just a way for us to organize our info. And then RT equals 4. Well, RT is the whole segment. So the way I like marking these is I like using a bracket, or I'm going to scroll up a little bit. You'll notice in the definition, we had these kind of more just kind of like what you would see in blueprints. It really doesn't matter what you choose to use, but pick a way to label your diagrams and stick with it. I like using the curly bracket, but that's just me. Okay, the whole segment RT is 4. So I still want to, hey, I have parts, I have the whole, part plus part equals whole. So part plus part equals whole. Again, you don't need to write out this map, but this is what you should be thinking. My two parts are 5x and 3x. My whole is 4, and it looks a little weird that 4 is a smaller number, but it's labeling the whole thing, so that's what I'm going to go with. So 5x plus 3x gives me 8x equals 4. I need to divide both sides by 8, so I'm actually going to write my in-between step on here, and you're going to see y in a sec. So divide both sides by 8, which means the 8's cancel, and 8x is equal to, well, 4 over 8. How can you simplify that? Well, that's actually a 1/2, or we could write it as a decimal, x equals 0.5 or just 0.5. Either one is fine. I am absolutely fine with writing either fraction or decimal answers. Just if you are working a problem online and it asks for a specific format, do read those directions carefully. Okay, so last problem, number 7. Wait a second, number 7 didn't give us anything except for info. We need to draw a diagram to make sure we can organize it all. So first sentence says point B is between A and C. Okay, so they haven't, and I'm reading the second piece with AB equals X and BC equals 2X. I don't see anything in there about angles, so I'm going to assume that this is a segment problem. Okay, so let's draw a segment. So point B is between A and C. So that means A and C have to be my endpoints. So here's my segment. Again, doesn't matter if it's perfectly straight, but kind of close. B is somewhere in between. I don't know if it's exactly in the middle, so I'm actually going to draw it off center. Okay, then I start labeling. So AB equals X. So our left-hand segment is X. BC equals 2X. Okay, so there's 2X. Again, I didn't draw it to proportion. That doesn't really matter. It's all about organizing your info. Last piece is AC equals 2x plus 5. Well, AC is the whole segment, so whole segment is 2x plus 5. So we need to think again. We have pieces, we have the whole thing. We need part plus part equals whole. So part plus part equals whole. Our whole segment was labeled as 2x plus 5. Our two pieces were x and 2x. So now it's just solving for x. So on the left-hand side, we can combine our like terms. X plus 2x gives us 3x. Right-hand side is still 2x plus 5. Okay, what do you think we should move first? So we could, if we wanted to, actually move the 3x. I would advise against it. So I'm actually going to move the 2x, combine my like terms as I can. So again, I'm going to go ahead and show my in-between steps on this one. So I'm going to subtract a 2x from both sides. So that's going to give me x on the left. And wait a second, the only thing left is 5. Hey, I got it in one step. Awesome. So x equals 5. Now, be careful when you're looking at some problems. You may actually need to substitute back in. So if I think back to problem number 4 that we were doing with angles, again, you'll notice I took my answer for the Q, and I actually had to plug it back in. So keep an eye out for those kinds of problems. You will definitely see those coming up. Read carefully. Is it asking for the entire angle or entire segment, or is it just asking for X and you have to substitute back in? Let me know if you have any questions.